Now, let's have a look at some modelling and problem-solving style questions. Here is one type of question we're going to come across. So you've been provided here with a list of data corresponding x and y points. I've gone and plotted those points and joined them up with a smooth curve. And it looks like it's forming a quadratic shape. So something in the form of y equal to a lots of x squared plus b. Now I know that there's got no single x term in there because it hasn't been shifted left or right. It's clearly its bottoming is here. So that's its turning point. So because it hasn't been shifted left or right, it's just going to be the x squared shape, just shifted up a little bit. If we can work out the values for a and b, we'd have a model that helps explain what this data is trying to do. And that's the essence of the question. What is the rule that produces these points, produces this graph? So we need to find the a value and the b value. Now in these types of questions there's numerous ways we can go about it. One particular method is it possible to turn our curved line into a straight line? Because a straight line is a very easy thing to work out the equation of. We're all familiar with y equals mx plus c, and b in the gradient, and c where it cuts the y-axis. If I could somehow turn this curved line into a straight line and work out the properties of that straight line, I could work backwards to find the a and the b value. How do I do that? Well, what we have here is it's a multiplied by x squared. So we all know that we take our x value and we square it. What I'm going to do is I'm going to actually work out x squared's values. So at the moment x is 0, when I square it, it's 0. X is 1, when I square it, it's 1. X is 2, when I square it, it's 4. 3 squared is 9, 4 squared is 16, and 5 squared is 25. Now, I'm now going to go and graph that and see what it looks like. Instead of the current graph which I've got, which is y versus x, so there's my y-axis and x-axis, so this is the graph of y versus x, just the curve. I'm going to go and produce the graph of y versus x squared. So across my horizontal axis, I'm not going to put the x values joined up with the appropriate y's. I'm going to put the x squared values joined up with the appropriate y's. So I've gone and done that. I've gone now and kept my y values the same, all these values here. And this time I've plotted them against not the original x's but the x's squared. I'm looking at that part there. So I've taken my y is equal to a lots of x squared plus b for the quadratic. Now I've taken that out and I've put in the actual x squared values. So what I'm going to do is I'm going to let capital X be equal to whatever x squared is equal to. So this equation here, the quadratic one, can now be written in the form of y is equal to a lots of capital X plus b. So I've taken, instead of x and then squaring them, so I've taken my x's, I've squared them, I've taken that out, put capital X in its place, I now have this function. This function here describes that result because when I plot y against the x squared, I end up with a straight line. As I said before, the equation of a straight line is very easy to work out. Now, notice that in this particular straight line, this is in the mx plus c form. So here, this value a is the gradient of this straight line. But this value a is also the coefficient from my quadratic. So if I could work out the gradient of this straight line here, I have the coefficient of x squared from my original quadratic. And if I can work out where this straight line cuts the vertical axis, b, I'm going to have the same value as my b from my quadratic up there. So by using my straight line, I can work out a and b very easily. I can then take that information and put it back into the original quadratic function, and I will have a rule that explains what these points are trying to do. Now, clearly the b value is really easy to do. It's just where it cuts the axis, and that's going to be 4. Now, you have got a whole series of points. You can take any combination of points here and using your gradient formula, y2 minus y1 over x2 minus x1, you'll be able to work out the slope of this line. So maybe combine that point with that point if you like. So you could go 14.8 minus 4 over 9 minus 0. Or you could use any other combination of points there that you like, and you'll get the gradient of this. Now, you could do it manually like this, but you could also do the following. Now, as I said, instead of doing it manually, you could also use a calculator to do it. So you could go to your list where you enter data, and you could enter all your x values in, and enter all your y values in, and plot those points, and you would end up with that shape there. Then you could also go and put these values into list 3 and plot y versus x squared, and you'd end up with that shape there. Then it's a very simple thing. Once you've got those points plotted with a scatter plot, you can use your calculator to work out the equation of that. So if you were to use your calculator to scatter plot those points versus those points and get that shape there, calculator will work out that equation for you. Now, so that's the gradient of it. And we've said here, that gradient there is the same as my a value from my original quadratic. So my original function over here that I'm looking for, y equals ax squared plus b. If I work out the equation of this straight line, the a value was 1.216. So my equation of my quadratic is 1.216 lots of x squared plus 4. You can work out, by giving us a set of data, plot it, you can see what shape it makes. This one's a quadratic. If you find a way to straighten the quadratic out, like I did here, work out the equation of that line, you're able to then work backwards from that straight line to work out the equation of the one that you actually want. That's one done with a quadratic. Next video, I'm going to show you how to do one with a hyperbola.